All right, so let's take a look at this thing, and I'll kind of get, somebody's already answered, all right. Somebody's pretty confident. Let's take a look. So I haven't given you one of these chart ones before, so I wanted to show you on a quiz so that you're not surprised at the exam. When is our exam? Next week? Or week after? Next week. So next, practice exam is Thursday, day after tomorrow. Real exam is next Thursday. We always put a week between those, so you have some study time in between. Yeah, so next Thursday. So I don't want you to be surprised, because there are these on the real exam, and there weren't any of them in the homework, huh? There weren't any charts like this, so I aim to not surprise you on the exam. That's my teaching philosophy, that you will have seen everything before you get to the exam. Okay, so how do you do this? Well, first off, the method is repetitive nearest neighbor. Repetitive nearest neighbor. So remember, we had 3 methods in this chapter. I'm on a bent to, I'm hoping you guys will do well. People have trouble with this material, so I'm doing all I can to hopefully you will do well. So let me review for you real quick. Remember, there's 3 methods for doing these find the cheapest route things, right? One of them is nearest neighbor. That's just go to the closest connection every time. This one's repetitive nearest neighbor. So that means you do it you repeat with each different starting point, always going to the closest. And then the third one was cheapest late, and that's where you look anywhere, right? Well, we'll look at those on the practice exam day again. So this is repetitive nearest neighbor, which means what? Which means you got to pick a starting point, any starting point. Let's just start at Boston, because that one comes first. So I'm going to start at Boston. I'll start at Boston, and then you just go to the nearest neighbor. So who's the nearest neighbor to Boston? This is the quiz question. Who's the nearest neighbor to Boston? Well, let me help you with reading this chart. As you go across the top, when it says Boston to Buffalo is 446, that's how far, right? When you go across with your hand and down, So Boston to Buffalo, 446 miles. That's how far apart they are. And Boston to Chicago, 963. Boston to, what is that? Columbus, 735. And Boston to Louisville. I lived in Louisville for 5 months. They don't say Louisville, they say Louisville. That's how they say it there in Louisville. So Boston to Louisville is 941. So that's how far. So what's the nearest neighbor to Boston? It is Buffalo, 446. That's the closest, smallest number. So that'd be the first. So you go Boston to Buffalo, and you want to write down the time, the miles, 446, because we're going to add them all up when we're done and pick the cheapest. So that's the first connection. And then you go, and by the way, I could have done that down instead of cross. All those same numbers are repeated above the diagonal and below it. It's all the same set of numbers. You can work with either set. It's all the same thing. You know what I mean? I could have just started Boston here and went, okay, 446, 963, 7, which one's smallest? Oh, this one, okay, Buffalo. Same information, huh? Do you see why the diagonals have nothing? Because that's same city to same city. How far from Boston to Boston? 0. How far from Buffalo to Buffalo? 0. Right? All the diagonals are same city to same city, so they're 0 distance away. Right? That good? Okay, so now we're at Buffalo. What's the nearest? So now you're sitting at Buffalo. You went from Boston to Buffalo. Now you're at Buffalo. What's the nearest neighbor from Buffalo? You can go to the Buffalo and go across, or you can go up to the Buffalo and go down, whichever you prefer. I'll just go across. From Buffalo, there's 446, 522, 326, 532. What's the closest? Yeah, the 326 to Columbus. You can... I don't know how to do it. Maybe whatever. It's running out of room, so I'll just go over this way. So to Columbus, and well, I don't like that. I don't have any room to write my number. So I'm going to go down, I guess. So from Buffalo, it's 326 to Columbus. Okay, so now I'm at Columbus. And so then you look across Columbus. You go 735, 326, 308, 209. What's the nearest neighbor to Columbus? Louisville, 209 to Louisville. Good so far. Now we have 4 cities, which means we only have 1 left. There's only 5 cities total, right? Am I missing one? Yeah, so we have 4, so we've only got 1 left. Remember, save yourself some time and effort. When you've only got 1 left, you have to go to that city. There's no choice. You have to go to the last city, and then you have to go home, huh? So what's the last city left? I'm not even going to look at the numbers. I'm not going to pick the smallest. Yeah, I've got to go to the last city, whatever it is. And what's the last city? Where the Dodgers are going tonight. Or they've already landed there, I'm sure. Chicago. Chicago, and how far from Louisville to Chicago? So look at Louisville to Chicago. There it is. Or you could do it in the other place. Chicago to Louisville. Right? Either one of those. 292, right? From Louisville to Chicago. 292. So there is the nearest neighbor trip starting at Boston. But we have to redo that whole thing now 4 more times. This is really painful because it's repetitive. If it just said nearest neighbor, I'd be done. That's it. You know, nearest neighbor, boom, done. But they said repetitive. Everybody getting the difference between those two? The repetitive, I'll give you at most 2 of those on the exam because those are long. And I won't give you any more than, I'll probably give you like 4 cities and 5 cities, and that's it. You know, these are the longest methods. So repetitive, you got to do each of them. So now, there's one answer. And what do those add? Somebody have a calculator? What do those add up to be, those numbers? So it's 446, 326, 209, and 292. I'll do it by hand. I'll race you. 11, 17, 23. Go ahead and yell it out if you got it. 11, 13, 17, 5, 8, 10. Did I get it? 1273. Did I win? Maybe I'm wrong, though. Somebody got it? 1273? Is that it? Thank you. So 1273 is the total for that. Oh, I didn't go home. Whoops. Forgot to go home. Chicago's got to go home to Boston. You got to make a loop. Remember, it's a loop. I forgot about that. So we got to go home in the end. We got to go back. It's a loop. You got to get back home. So how far from Chicago to Boston? Chicago to Boston, about 9. Ooh, that's a bad trip. 963. So we got to add 960. Somebody add 963 to that for me. That's going to wreck it. 2,236. So that's the round trip starting at Boston. The nearest neighbor round trip starting at Boston. Now you got to redo that whole thing. This time, starting at Buffalo. I'm just going, you can start anyway. You got to do all 5 of them eventually. So now, let's do the whole thing starting at Buffalo. So starting at Buffalo, who's your nearest neighbor? Who's your closest neighbor? Look across. 446, 522, 326, 532. Looks like 326, right? Lowest number. I just go across the row and find the lowest number. So 326 to Columbus. Write that number in because you do need to know. You're going to add them up when you're done. See, we're going to take the cheapest overall trip when we're done. We're going to have 5 of them, 5 loops. It's going to be real tedious, and then we'll pick the overall lowest as the best answer. So now from Columbus, who's your nearest neighbor from Columbus? Look across the Columbus road. 209 to Louisville, right? 209 to Louisville. And then from Louisville, go across the Louisville road. Who's your nearest neighbor from Louisville? 209. Oh, that's Columbus. We can't go back to Columbus, right? So we can't do that. You with me? So I can't choose the 209. What's the next cheapest number? Chicago, 292. So take Chicago. 292 to Chicago. And now, at this point, I've got 4 cities. So don't mess around wasting your time looking at numbers. You've got to go to the 5th. When you've only got 1 city left, you've got to go to that city and you got to go home. So which city's left? What is it? Oh, it's Boston. It is Boston. Yeah, I got to go to Boston. How far from Chicago to Boston? Yeah, a long ways. 963. And then from Boston, you got to go back home to Buffalo. How far from Boston back home to Buffalo? 446. So can somebody add all those numbers up for me? Let me know what the total of all those is. I'm thinking 22 something again. 22, I'm sort of guessing.
2,236.
36. Same exact total as the other one. What do you think that means? It's the same loop. I bet it's exactly the same loop, just starting at a different point. How do you know? Well, let's see. Starting, you can start, it's a loop, so starting where you want. Start at Boston. Start at Boston. What comes next? Buffalo, sure enough. Columbus. Louisville, yeah. Chicago, yeah. Back to Boston. That's the same loop. Now, they won't always be the same loop, but those two are the same loop, just starting in a different spot. So that's my second one. I got to do all 5. Now, start at Chicago and do the whole nearest neighbor thing. When you're done with that, start at Columbus. Do the whole nearest neighbor thing. Start at Louisville. Do the whole, when you have all 5 of them down, all 5 loops, take the one that's got the lowest total. Lowest total. That's the answer. Right? So I'll go back to the main screen. I'll let you finish it now. Everybody got that? So that was 2236 was the total for those other 2 loops. 2236. And by the way, look at how here's what confuses a lot of people on the test. I'm trying to say it just as clear as I possibly can so that you will not be fooled on the test. A lot of people, I think, see the Louisville answer starting, and they think they're just supposed to start at Louisville, and that's all they're supposed to do. How do we know that's not right? Because they said repetitive somewhere. Oh, right here. Repetitive nearest neighbor. So even though the final answer has Louisville, that doesn't mean the Louisville one's going to be it. Are you with me? Am I confusing you? Make sure you understand. If you don't understand these words, you're in danger for the exam next week. It could go really badly for you. That's what happened to people. So let me say it again. And if you're still not getting it, grab me after class. I'd be glad to talk to you more about it until you've got it. Look. Oh, I'm not on this laptop. Let me go back to the laptop and show you what I mean. What do I mean you don't do the Louisville one? They're all Louisville. What am I talking about? I mean, you could read, the answer could be this one, for example. I don't know. I'm not done yet. I haven't done all 5. But say the answer ends up being this one's best. Well, maybe all the other ones are in the 3000s or something. I don't think so. But what if this one's best? I could rewrite this one starting with Louisville. Remember, it's a loop. So don't be thrown off by how they wrote the answer. Any of them could be rewritten, starting in any city. You realize that? Everybody hearing me on that? I could write, look, I can start here, look. Louisville, I can start at Louisville. Louisville, Chicago, Boston, Buffalo, Columbus, I was going to say Colorado. Columbus, back to Louisville. Whatever. I can make any of these starting with Louisville, right? So don't be thrown off when you see those answers all start at Louisville and go, oh, I just started Louisville. No. They did them all, and they took the winner and rewrote it starting with Louisville. They didn't just start at Louisville, right? Everybody seeing that? I think that's what happens to people a lot, is they just see the final answer, and they miss the most important word in this problem, which is repetitive. Repetitive, nearest neighbor. So you have to do all 5 and take the winner. All right, so I'll quit talking, let you do that. All right, so we got the Chicago loop. Now there's the Columbus loop. What's the closest to Columbus? Louisville, 209. Closest to Louisville, Chicago, 292. Closest to Chicago, looking up here at the Chicago numbers. Louisville, but we can't go back there already. Columbus, can't go back there already. 522 to Buffalo.
Actually, the Chicago one to Louisville is 2,409.
The green one? 2,209.
I think it's 2,409.
2,409?
Yeah, that's what I heard. But sorry. I didn't check it.
It ends with a 6. That much I can tell. So it's not anything ending with a 9. I'm just adding up the ones digits, and I can tell it ends with a 6. So it's probably the 2236. That's probably right. Yeah. Yeah, I think it is 2236. Can you guys read my writing? 963. This is 446. 326. 209. This is 9. 292. You know, when I took tests and I had real problems that had a lot of calculator and this like this, real intense with the calculator, I would just run them twice because it's so easy just to hit a wrong button, and I didn't want to lose points on tests mindlessly, needlessly. So I would run the calculator twice. If I get the same answer twice in a row, I would know I didn't hit any wrong buttons. I get two different answers, I'd slow down and go, oh, wait a minute, and do it more slowly. So keep going. After Buffalo, is that it? Oh, it's the only one left. Yeah, guess so, huh? Boston, Buffalo to Boston. We're always doing Buffalo to Boston. Again. And then back home to Boston to Columbus, 7:35. Don't tell me it's 22:36.
It's 2204.
Ah, 2204. So that's better than all the 2236s. Yeah, and I just added the ones. Here's a good way to check too. When I'm doing this, I'm just adding the ones digits to make sure it ends in a 4. I'm just going 5 and 6 is 11, that ends in a 1. And 2 is 3. And 2 more is 5. And 9 is 14, ends in a 4. I go, oh yeah, that's probably right. Got the right ones digit. Just another way to double check. Sometimes in life, you need to just get it right. Right? There are times, I know we often say, well, I'm not perfect, and yeah, but there are ways to double check and do things really, really careful so that we, when they build bridges and they do things and the doctors cut you open, you want them to get it right. You don't want small mistakes. There are times to get it right and to make sure you get it right. Right? So that's part of what this class is about. Do things, make efforts to get it right. You run your calculator twice, add up the ones digits, do things like that to make sure you get it right. So we got one more to go. Louisville. Let's start at Louisville and run those. So far this is the best answer, isn't it? So far this is the winner. He's the lowest total. And we can rewrite him starting with Louisville. But we still have to do the Louisville route. So I'm going to erase some of this other stuff. All this stuff. And do the Louisville route. It's the last one. The Louisville route. And maybe that one will be it. I don't know. So start at Louisville. What's the closest one to Louisville? Right here, 209. Right, I'm just looking across the Louisville road. Just saying how far, 209. That's to Columbus. 209 from Louisville to Columbus. And then from Columbus, what's the closest? Well, 209, but we can't go back to Louisville. So 308. 308 to Chicago. 308 to Chicago. And then from Chicago, From Chicago, what's the closest? 292 to, what is that? Oh, no, I can't go back to Louisville. No, that's not allowed. So no, can't do that one. 308 to Columbus. No, I can't go back to Columbus. 522. Wait, I'm getting confused. Yeah, no, that's right. 522 to Buffalo, huh? So 522 to Buffalo. Okay there? And now I've got 4 cities. That means I'm not even going to look at the numbers. There's only one left. Which city's left?
Boston.
So what is it? Yeah, Boston. Okay, go to Boston. How far from Buffalo? It's always Buffalo to Boston at the end, isn't it? 446. Always. And then from Boston back to Louisville, got to go home. Boston back to Louisville. Louisville to Boston. 941. That's going to wreck it. It was good before that. 941 from Boston to Louisville. So if you add up those numbers, somebody got those totals?
2,426.
2,426?
Yeah.
It ends in a 6. I just verified the ones digit. That's not the best answer. That's the worst answer, isn't it? So we have our winner, 2204. That's the lowest total. Now you have to rewrite, so it's not the one that started with Louisville. That's the mistake a lot of people make. So now you got to take that answer and rewrite it starting with Louisville, don't you? Because all the answers started with Louisville. And there's 2 ways to do that, remember? You could go Louisville to the right, Chicago, Buffalo, or you could go left. There's 2 ways to do a loop. And the answer could be either one of those. They're both a loop starting with Louisville that's the best loop. Right? You guys seeing those kind of things, what I'm talking about? So I would take that answer now and write it 2 ways. I would say, okay, I got my final answer. Final answer then is this guy right here. He's the best one. So I'm going to start him with Louisville. Start right here, Louisville, go to the right. Chicago, Buffalo. Chicago, Buffalo, Boston. And then Can't read my writing. Where's that go from there? Goes that just back to, oh, then it goes back. It loops back to Columbus. Oops. I'm running out of room here. Buffalo, Boston. Columbus. And then it goes back to Louisville. That's one way to write it. The other way is to go left. Start at Louisville and go left. Go Louisville, Columbus, then come over here, Boston, and then Buffalo, Chicago, and then back to Louisville. That's the same loop, run forward, run backwards. And that's the best loop. At least the best one the repetitive nearest neighbor method gave us. There's other methods. Right? So either one of those could be the right answer. Right? Did you track with all that? So click in the right answer now. You guys are wondering, what are the answers, Mr. Aaron? There they are. So click in the right answer. I'll give you 20 seconds. Wait, do you see the right answer there?
Yeah.
Oh, I must be missing something. Okay, look this one. Oh yeah, Here, yeah, there it is. Do we all get the right answer? Are we good? We have that? We all in? Last call? I think we're all in. There's 22. That's probably it. Ready? I'm going to close her down. 3, 2, 1. We got 100% right? Let's see. Ooh, close. Yeah, let's see. It's D, right? Two people didn't get it? No? The answer was D. Did you see it there? See how D has it? Louisville, Chicago, Buffalo, Boston. Right? If you go back to the laptop here, right? That was the answer. Louisville, Chicago, Buffalo, Boston, Columbus, and then back to Louisville. That was the answer. Let's go from there. Okay, so this is section 8.3, problem number 1. And what they want me to do is 2 processors, means like 2 employees, right? 2 workers, and they want me to use decreasing time. What does that mean, decreasing time? Highest jobs first, right? High to low. High to low. It's just simply what it means. Decreasing, going down, high to low. Okay, so here we go. We're going to schedule 2 processors. Remember how this whole thing works? So processor 1, processor 2, and we have the time at the top. This is time 0. All right, so which jobs, what are our options? We're the manager. We're going to come in and we're going to say, all right, employee number 1, I'm going to give you a job to do. What options, for, starting at the map, looking at the map there, starting the arrow diagram, the digraph thing, so a project digraph. So starting there, what jobs can we begin with? Yeah, you have to go to either A, C, or E. You can't go beyond that for the start. So how do you know which one you're going to do? A, C, or E? So I'm going to write options, A, C, or E. You can go to any of those 3, A, C, or E. Any of them are fine. Yeah, and then how do you know whenever you have options, and you don't always have options, usually in the beginning for sure, and maybe later, but not always. When you have options, that's when you go back to your priority thing, whatever they tell you the priority list is. And in this case, they're saying decreasing time. Sometimes they say alphabetical. Sometimes they'll say, just go by the alphabet. If A is before B, do job A before B. Sometimes they'll give you a certain list. They'll say, do it in this order, D, G, E, F, whatever. They'll just give you letters. Sometimes, now this time they're saying decreasing time. So that means look at A, C, and E, start with the highest job. That makes sense, doesn't it? Trying to get on the highest job first as a priority, get that done first. So A, C, or E, which one has the highest time? A is a 6-hour job. So let's do A first. So 1, 2, 3, 4, 5, 6. 1, 2, this is the time up here. 4, 4, 5, 6. So I'll give processor 1 job A, and it takes him 6 hours. Now, processor 2 needs a job also. So that's either going to be C or E, and we'll do E, because E is higher than C, right? Start with the highest jobs. So give him E, which is a 4-hour job. We good? This is the 1, 2, 3, 1, 2, 3, 4. 4-hour job, E's done. Okay, now, can you do the next step? Remember how this works? Can you do the next step? Assign the next job to the next person that should get a job. So who gets a job next? Processor 2, because he's ready first, right? At 4 hours, processor 2 comes back to our office and says, I'm ready for another job. Processor 1's still working. So processor 2 says, I'm ready for a job. So we look at the map and we go, okay, you're ready for a job. You just finished job E. Processor 1 is working on A. So what's available? What's available? Now be careful here. This one's a little tricky. Did you guys get, let me give you 30 seconds more. So go ahead and give processor 2 the appropriate next job. Give you just a second. So, again, job E is done. And at this point in time, at 4 hours, job E is done. Job A is still being worked on. So what jobs are available? C and F. F's available. Right? E's done. F is available. Not just C, but F. Everybody see that? Both F and C are available. You can work on F now because he's done. Or you can work on C. Both are available. Everybody see that on the map? So C's available and F's available. D's not available. You can't do D till after C. B's not available because A's not done yet, still being worked on, at least at 4 hours. I'm at 4 hours right now. Always got to put yourself in time, right where you're at in time. Right? You guys ever seen the movie, what's it called? Live, Die, Repeat. You know, a lot of movies do the time thing. Tom Cruise, like 5 years old. I thought they did very well with the time thing. I love this song. You know, I bought the movie, and every now and then we're sitting around, there's nothing to do. I go, we could watch Live, Die, Repeat. They're like, Dad, we've seen it like 5 times. You've got them all memorized. Anyway, I thought they handled the time element very well, very realistic. Anyway, there's my little sidebar. So, you got to put yourself in time. You're at 4 hours right there at 4 hours, and you're thinking, okay, what's going on at 4 hours? Job E is done. C and F are available. So which one will be worked on? F. Remember, you take that when you have choices, you take the higher time. That's what decreasing time means. Everybody catching the significance of decreasing time? That means you go higher to lower, right? Decreasing. So you're going to do F first, actually, because that's a bigger job. You want to get the bigger jobs done first. So you're going to start with F. So F, actually, that's how long? 3-hour job? So that's 5, 6, 7. So go out to 5, 6, 7. That's F. 3-hour job. Everybody good with that? That makes sense. See why it's F, not C? F's a little higher. That's kind of little stuff that trips people up. Okay, go ahead and do the next one. Give whoever needs a job the next job. You've got to put yourself in time, as it really is. Okay, so the processor 1 needs a job. He's at 6. Put yourself in time at 6 hours. Processor 1 at 6 hours. Let me go back and fix the map. At 6 hours, you always got to kind of put yourself in time. At 6 hours, job A is done. Job E is done. Job F is being worked on at that point in time by processor 2, right? So what jobs are available? B and C are both available. Everybody see that? For processor 1 to work on, both B and C are available. Which one will we go with? the bigger one, the bigger job C, 2-hour job C. Everybody see that? So that'll take us from 6 to 8. Job C from 6, 7, 8. Is that good? Everybody okay? Go forward in time to the next time a job is done. When's the job done next? 7 hours, right there. Okay, give them the next job. So so E and F are done now. A is done. C is being worked on at this point in time by processor 1. So what jobs are available to processor 2 then? What jobs could I put here? D's not available. Only B. Right? Because C's not done. At this point in time, at 7 hours, up here, that's the middle of job C. He's still being worked on. He's not done. Everybody with me on that? You really got to focus on the time element. You got to realize where you're at in time. Job C is still being worked on. It's not done, so D's not available. That's the mistake a lot of people make, is they'll stick in like job D right here. That can't be. You cannot start. They're starting job C at 7 hours, and C is not done till 8 hours. That can't be. Right? So watch out for that little stuff. That's what'll separate the right answers from the wrong answers on the multiple choice thing. Is all that kind of. That's the main thing they do to try to trick you on the multiple choice options. You'll see when you get to practice on Thursday. Is they try to like stick a D in here. You watch that. Go, oh, no. D can't start before C's done because D comes after C in the map. That's how they try to trick you. So watch out for that. So we can't start D there. We have to do B. Whoops, I just erased it. B, which is a 1-hour job. Does that make sense? And now at 8 hours, everybody's available, and there's only one job left, right? A, B, C, only D? Yeah, 5 hours. Who gets it? The top guy. Because when they're both available, you always start with the top guy. So the D gets it. So what, a 5-hour job? 5. So 8, add 5. What's that, 13? I just added 5 there because it's a 5-hour job. And now what is the other, there's no other jobs to do for processor 2, so he is idle. This is idle time. From 8 to 13 has nothing to do. Wasted time. That's what we try to minimize, right? That's considered bad management if you have your employees standing around doing nothing, right? That's where we're trying to use math to help us manage things well. So there we go. We finished the job, 13 hours. There's 5 hours of idle time. That's the map. That's the schedule that happens using the decreasing time algorithm, the decreasing time method. There's other ways we could have done those jobs with other priority schemes. And we're wondering, is there a better way? Is there a better way to not waste 5 hours? Is there a way we could have got this job done in maybe 12 hours, 11 hours, and not had so much wasted time? I'm not sure. We'll see as we go. I'm not sure about this particular one. There is a better overall plan. I know that. Good? Does that make sense on that? Questions? So then you just go back and pick the right multiple choice answer, whichever one is ACD on the top, EFB on the bottom. So basically, what we're looking for is a smart way to do this, right? A way to be a manager who manages the jobs without wasting time as best possible. So what is it? The best way is actually going to be called the critical path algorithm. It's this. We were thinking that if you're having employees work on jobs, can you guys read that map? Is that too? I can't really blow it up too much unless you can kind of see that. This is the map. This is the most important part. Put that on your notes. So, all right. So looking at that map, we've been thinking up to now, well, you should start with the biggest jobs first, right? Get the biggest jobs out of the way first. That's almost right. There's one thing more important than biggest jobs first. It has to do with how many big jobs are behind it, right? If you have just a simple job, 1 hour, but behind it is a bunch of 20-hour jobs, really you better get on that 1 hour job as a priority so you can get to the big jobs behind them. You know what I mean? So it's not just how many hours is the job right in front of your eyes. It's how many hours all the way to the job end that job leads through. It's the path. That's what they call it, critical path. So it's not just about doing the biggest job, it's about doing the biggest path first. That's really efficient management. So what am I talking about? Let me show you. So here's how we do the critical path thing. I'm gonna make that map bigger, and I'm gonna get rid of the table, and we'll go back and do the table. That's boom, 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 boom. Okay, there we go. So yeah, so let's do that. What's critical path? We're gonna put here in brackets a 0. Trace with me for a minute. You guys have that map on your paper there? We're gonna put bracketed numbers next to each of the letters. Even though they've already got parenthesis numbers, the parentheses are how long the job takes, right? And then we're gonna add up from there to the end. So let's do this one right here. I'm gonna add backwards. So this is 0 plus 6 is 6. 0 plus 3 is 3. Looks like nothing so far. Add 13 is 16. Let me slow down. Does everybody see what I'm doing? I'm adding backwards. So I took that 0, add 3 is 3, add 13 is 16. So I'm just adding as I walk backwards. Why? Because that tells you how long from there to the end it takes. In other words, to do E all the way to end would be 13, 3, done, which is 16. That 16 is telling me how much from E to the end, how much that path from E to the end will cost. Does that make sense? That's what we really need to look at, is how far to the end, how much the path costs. We need to get on the bigger paths right away. Get the employees working on the bigger paths, not just the individual jobs. Okay, one more. So to define that, you just add backwards. So the next one, just add 7. What's that, 23? Yeah, 23. So see what I did? I'm just 0, add 3 is 3, add 13 is 16, add 7 is 23. So I'm just adding backwards. It's basically all it is add backwards. But there is one trick. If you have 2 options, you take the higher one. Let me show you. Let's do the top now. 0, add 6, add 3. So what's going to be above D here? Or no, add 5. I'm sorry, add 5. What's going to be above D? 11. Everybody good with that? See what I'm doing? Exactly right. So I went 0, add 6 is 6, add 5 is 11. Good so far. And now, what do you do with that 11? Again, we're doing the arrows backwards. Add 9 and add 2. Right, separately. You just keep them separate. 11 add 9 is 20. 11 add 2 is 13. Like that. We good to there? So I'm just walking backwards. Just adding as I go, walking backwards, adding as I go. So now, when I come back to the start, I actually have 3 ways to get back to the start. I have options. This is the first time in my backwards walk that I have had options, isn't it? Well, okay, so which option will you take? Highest. Whenever you have options, don't add them all up. That's a mistake a lot of people make. They add them all up. No, we don't add them all up. We take the highest. So I'm looking at 23. That could go back to start. 13. That goes back to start. Or 20. That goes back to start. Which one will I take? The 23. So 23. It's the highest one. Add 0. So that's still just 23. And there we go. We put bracketed numbers next to every job. What do those numbers mean again? How far from there to the end, worst case, highest total. So from the start to the end, 23 hours of jobs. Best case. Well, worst case. 23 hours, right? The longest road from the start to the end is this road, which takes 23 hours. There's 23 hours of jobs that have to be done one after the other. In other words, it doesn't matter how many processors you put on this job, you're not going to get it done before 23 hours. That's what that tells you right away. There's 23 hours of jobs that need to be done one after the other to get to the end. Okay, now, so when we go to make decisions, we're gonna use those numbers to help us know what job to do next. Always going with the highest bracketed number, because that's the highest path. So we're not going to pay attention to the parentheses numbers anymore. Everybody understand the difference? The parentheses is just how long the job takes. The bracket is how long from there to the end on the path. Okay, so that's what they want on the table. So go back to this question. That's how they got all these numbers. We've already got them. Is that good? So then they'll say, find the critical path, which means the highest path. What's the critical path? What's the 23 path? It's this path right here. Where, let me change the color or something. It's this path right here. That's the highest number path. That's what they mean by the critical. In other words, it's critical that you get on that path right away. That's gonna be the one that's gonna use up the most of your time. It's critical you get on that path. So start to C, to E, to G, to end. That's the longest path in the map from start to end. It's the critical path. Start, C, E, G, end. Let's go see it. Start, C, E, G, end. That's the right answer. The red is when I guessed wrong. I just guessed real quick to get the right answers on the screen. The green there is the right answer. Everybody good so far with questions A and B? Getting the bracketed numbers, finding the critical path. Now they're going to have us actually make a schedule based on all that. This map right here on the screen. And now let's actually do a schedule. I mean like a processor 1, processor 2. That's what the schedule means. And let's actually do it. Maybe I better move it down so I don't get in the way of that other stuff. And we're going to use the bracketed numbers to do it. So they're going to say processor 1, processor 2. And I'm going to schedule, this is part C, schedule according to the critical path algorithm, they call it. Algorithm, it just means steps to get something done, like a recipe. Critical path algorithm. So that means whenever you have options, pick the higher bracketed number. That's what critical path algorithm means. All right, so here we go. Processor 1. What jobs are available for processor 1? Start there. So don't worry about the bracketed numbers right now. Remember, the main thing is the map before anything else, the map. So looking at the map, here's the start. What jobs can we go to first? A, B, or C? Right? I'm not even looking at the numbers right now. But the map is the main thing. Numbers are all secondary. Even these bracketed numbers are less important than the map. The map's the main thing. So looking at the map, A, B, or C. Which one? So now we have options, huh? Options A, B, or C. So my options are A, B, or C. So A, B, or C, which one will I do first?
C.
Yeah, you look at the highest bracketed number. Right on, C. Notice I'm not picking A, which actually has the highest parenthesis number. It's the highest. A takes 9 hours. It's a longer job than C, which only takes 7 hours. But C's on a more important path. There's more work behind C. It's the critical path. Does that make sense? See the difference? So if this problem said, make a schedule by decreasing time, I'd be going with A first. Because decreasing time doesn't have the bracket numbers. It just looks at the parenthesis. You guys tracking with me on that? That's the problem we just did. Right? We did decreasing time. And so I would look at the highest parenthesis time, 9, and start with that. But if we're doing critical path, I look at the highest bracket number and start with that. So that's the 23. So I'm going to start with job C. How long is job C? It's still only a 7-hour job. I don't do 23 hours. It itself is just a 7-hour job. It's just on a path, which takes 23 hours to get to the end. 7-hour job. So here we go. I'm going to do 7 hours for job C. 0, 1, 2, 3, 4, 5, 6, 7. Oops, not both. Just that one, huh? 7-hour job for C. So there we go, processor 1, 7 hours for job C. All right, can you give processor 2 a job? Go ahead and do that. Do processor 2. Second. So see if you can take a couple steps rather than me just doing it. I think you'll get more out of it. Try to do a couple steps and I'll jump in a second. See how you're doing. Processor 2, what job am I going to give to processor 2? Yeah, it's going to be, the only choices are A and B, right? Only A and B are available right now. And the higher path is A, not 9 hours. So this will be 7, 8, 9 hours. So A will be 9 hours. Is that good so far? A is a 9. We give job A to processor 2. Is that okay? So now you go to the first completed job. So what's the first completed job? C is done at 7 hours, and processor 1's ready for a new job, right? So go ahead and give processor 1 his next job. So processor 1, so you always got to kind of remember where you're at in time, right? So where are we at? C, at this point in time, job C is done. Job A is being worked on. So what's available? B and E are both available. Does that seem right to everybody? Everybody see what I'm talking about? B is available, has been available for a while, and E is also available. Yeah, E has the higher bracketed number. It's got the more critical path. So again, it's not because of the parentheses. If I was doing decreasing time, it would be because of the parentheses, right? But when you're doing critical path, it's all because of that bracketed path number. See the difference there? So the higher bracketed number means we choose E, because that means his road is longer. There's more work behind him. So we choose E, which is a 13-hour job. So that takes me from 7, add 13, takes me out to 20. 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19, 20. So there's 20. And that was, what was it, E? That was job E, 13-hour job. Don't confuse the parenthesis numbers with the bracket numbers, right? The parenthesis is how long the job takes. The bracket is the path, or the path, how long all the jobs till the end take from that spot. So E, so now processor 2 is ready for a new job. So give him a new job. So you're putting yourself in time right here. Right, you're going back in time. That's why I'm referencing that movie. Back in time to the spot you're at in time, and think about what's going on in time at that spot. A is done. C is done. E's being worked on. What's available? Only B. Yeah, D is not available. Is everybody clear with that? You can't do D till both A and B are done, huh? Right? You can't do D yet, so only job available is B. I don't even have any choice. I'm not even thinking about that. The only job available is B. Huh. There's nothing else available. B. B's only a 2-hour job. That's going to be 10, 11 right here. B. And so processor 2 is done with B, and he's ready for another job. We cross off B. So at this point, A, B, and C are done. E's being worked on. So what jobs are available?
D.
Only D. D is, again, I'm not even thinking about numbers right now because it's always the map first. And if the map only gives me one choice, I just go with that choice. The map's saying the only thing you can do is D. That's the only job available. Because A, B, and C are done. E's already being worked on at 11 hours. Processor 1's in the middle of E. So D is the only job available. Jump on D. That's a 5-hour job. So 12, 13, 14, 15, 16. That was, what was that? That was E? No. D. D. Good to there. And now we're at the next completed job, which is D. D's done now. Yeah.
You're not using the one in the red brackets anymore?
Red brackets. I'm not.
You used it on the first 23 though, right?
I did. Because, and you see why? Is that it's a good question. The reason why is because I don't have any choices. So if the map only says there's only one job even open, then I don't care about any of the decreasing time, critical path, whatever. Who cares? Just do that job. There's no choices. But if there's a couple of choices, then I go, well, which one should I choose? And then I go to the red bracket numbers, or if we're doing decreasing time, I look at the parenthesis numbers, or if we're doing alphabetical, or whatever they say to do. You only do that when you have options from the map. If the map only gives you one choice, you just do what the map says. But if the map gives you some options, 2 or 3 choices, that's when you pay attention. Does that make sense? So like in this last step, I had to do D. It doesn't matter what the numbers say. D was the only job available, right? Because A, B, and C were done. E's already being worked on. D's, I can't do F for G. E's already been worked on. D's the only choice. So the map only gave me one choice. I didn't need to look at any numbers anywhere. So now D's done. D's done. So A, B, C, and D are all done. E's being worked on right at this point in time. Put yourself in time at 16 hours. A, B, and D, and C are done. E's being worked on. Got a few more hours left on E. So A, B, C, and D are done. They're crossed off, crossed off. E's being worked on. So what jobs are available? Only F. Again, I'm not going to look at any numbers. The map's only giving me one choice.
What I did was I messed up, but I jumped from C to B because I thought the 13 was in the red parentheses.
From C to B. So you finish job C and then put B right here?
Yeah, I put B because I thought the 13 in the red brackets was the time left.
Yeah, it was. But the reason that E came first is because E has a 16, which is higher than 13. Does that make sense? Yeah, no, you were right to look at the red bracket numbers, but you take the higher one. So the E had a higher red bracket number. So not the parenthesis number, but the red bracket numbers. E had a 16.
Oh, I thought maybe B and then, like you had to do them order.
What order?
Like all the ones lined up A, B, C had to be done before you could even move.
Yeah, no, it's not that. Good question. Good. I'm glad you're pointing that. Everybody seeing that? That's a really, I think people think those kind of thoughts. No, like, you gotta finish all these before you do these. Not so. Not so. You just gotta follow the arrows, whatever the arrows say. And the arrows here say that that C was done, so you could go to E before you did B. Yeah, good. I'm glad you bring that up. Good job highlighting that. That's exactly the issue, I think, that stumbles people. Is everybody seeing, especially why I did E here before B? Because E had a higher bracket number than B. Yes, it doesn't matter where you could be way off in the end on one of them and way like you're on the other. It's whatever the arrows and the priority list say. All right, so D's done. The only job available is F. F is 6. Do job F, which is 6. Oh, wait, I shouldn't cross it off yet. That'll take me to 22, won't it? 21, 22. So that's F. 17, 18, 19, 20. 17, 18, 19, 20, 21, 22. Job F is done at 22. Only other job is G, right? G is 3. It's done after E's done. So that's 21, 22, 23 for job G. 3-hour job. There we go. So from 22 to 23 is idle time for processor 2. That's pretty good scheduling, isn't it? Only one wasted hour. That's a way better way to schedule jobs, is by critical path, looking down the whole road instead of just at the individual job. See how it worked better. Make sense? Questions on that? Not going to have time for a lot more. I'm going to do maybe one more. But that's it. I mean, I'll have any... Oh, I got a couple little formulas maybe I need to show you. But nothing major. That's the major thing is that. Is that no other questions on that? Is that good? For our last 5 minutes here. So number 4, independent tasks. Okay, so this changes everything. Actually makes it easier. This is going to be way easier. But you do need to notice the word. It changes everything. When they say independent tasks, what does that mean? No map needed. That makes it so much easier. No map needed. Now why? Because the tasks are independent. You don't have to do one thing before the other. You can do them in any order you want. Like coming up on Thanksgiving. My wife will be hosting a lot of people. And I'll just be goofing around the house. But my wife will be hosting a lot of people. All of our family will come to our house this year. Anyway, so she'll cook a lot of different things. It doesn't matter what order. Well, it probably does. I don't know. But mostly it doesn't matter. You can cook the stuffing anytime you want, then the turkey after, the turkey before, the stuffing after, the pies the day before, the whatever. The order doesn't matter. You just got to do all these different jobs, do them in whatever order you want to do them, right? You don't have to have the pies done before the turkey. You don't have to have the green beans done before the stuffing. You know, it's really whatever order. Whereas if you're building a house, you've got to have the floor in before you put the walls up. You just have to. You got to have the walls done before you put the roof on. You can say, well, I'm going to start with the roof, do the walls later. That just isn't going to work, right? So there's certain jobs where the order is essential. You have to do certain things before certain things. There's other jobs where they're kind of independent of each other. It doesn't matter what order you do them, and just get them all done. That's what they're talking about here. These are independent. So order doesn't matter. Order does not matter. So we don't even need a map. We're not even going to draw a map. We don't need a map. Who cares what you do before what? Just get them all done. Okay, so if that's the case, it'll be a lot easier to schedule. Schedule a job with 2 processors using critical path. What does critical path mean? Highest first. Right? Highest first. Critical path. So, what are the tasks? They're right here. Instead of letters, they're just giving us numbers. They're just saying, here's the jobs. A, I can make it up, there's no A's. But one of the jobs is 2 hours, one of the jobs is 3 hours, one of the jobs is 5 hours, etc. Those are the different jobs. Those are the different jobs we're going to do, and we're supposed to schedule them starting with the highest numbers first. So you can see the right answer right here. See how they started with the 11-hour job first, the biggest time. Then they did the 10-hour job right below it, the next biggest time. And then after the 10-hour job finished, then they did the 8-hour job, because that was done before the 11 was, right here. The 8-hour job, which is next. Then the 7-hour job, which is next. It kind of looks the same. Where do they get different? Oh, next, this one is wrong. See how this is wrong right here? That's why that's not the right answer. Because why? What's wrong about it? At this point in time, see how he did the 3-hour job before he did the 5-hour job? That's wrong. What am I talking about? Remember, you always start with the top processors. He should not have done the 3-hour job before he did the 5. That was out of order. So that's why that's not the right answer. The 5 comes before the 3. Down here it's wrong. Why? Because they started the 7-hour job before the 8. See how that's wrong? So you're supposed to go highest to lowest. So, no map needed. Just go highest to lowest. No idle time. Just crank them all together. Is that good? Is that easy? We're kind of out of time, aren't we? So we're going to have to stop there. I did not quite finish.